right, guys. Hi there. Let me get this started real quick. Okay. I need to erase everything that I just did because I already recorded a video with no sound, so that was fun. So this is going to be a little bit faster because I'm a little crunched for time right now. Okay, guys, while I'm doing this, please make sure you have your name and date on here. And you can go ahead and read the first question. Okay, so our first question says, well, first our learning goal is let's look at scatter plots as a whole. We're going to be analyzing those and kind of figuring out what everything about it means. Our first question is, if a car weighs 1,750 kilograms, would you expect its fuel efficiency to be closer to 22 miles per gallon or 28 miles per gallon? Go ahead and pause the video and see which you think based on the graph, okay? Make sure you explain your reasoning using claim, evidence, and reasoning, okay? All right, hopefully you guys chose closer to 22 miles per gallon. If we look on the graph and look at 1,750 and go up, we kind of have 2 points we're looking at. One is here and one is here, okay? Your claim should be that it is closer to 22 miles per gallon if a car weighs 1,750 kilograms. And then your evidence should be these 2 points because those are the closest weight to 1,750. And if you look, one is about 21 miles per gallon and the other is about 20. Okay, so you should explain that in your evidence. Is using those 2 points, your reasoning is explaining why you chose to use those 2 points. So because one is probably like 1,775, which has 20 miles per gallon, and one is maybe 1,700, and that one has about 21 miles per gallon, okay? So we would expect this fuel efficiency to be closer to 22 miles per gallon than 28. Okay, make sure you had full sentences in your response. Okay, next we're looking at a scatter plot about the weight of a diamond and price. As you can see, as the weight increases, the price also increases. Now, on this graph, and I want you to label this, this is a line of best fit. Okay. Now, I want you guys to go ahead and pause this video and try these next 4 questions based on that scatter plot. Okay, and then we'll go over them when you come back. Okay, so our first question says 2 diamonds that both weigh 1.5 carats have different prices. What are those prices? Well, if we look at the weight of a carat as 1.5, we see one is 6,000 and one is 7,500. So we can say, oops, we can say 6,000 and 7,500. Okay, the model predicts that when the weight of a carat is 1.5, when the weight of a diamond is 1.5 carats, the price will be 7,189. How can we see this in the graph? And that's because this is where the line intersects. It's the point at which the line of best fit intersects the graph. Okay, find the diamond for which the model makes a very good prediction of the actual price. How can we see this? Well, if you look, there's probably like 3 we can use. One here, and one here. Let's focus on this one, which is about 1.21 carat size and $5,500. Okay, and this is because it's closest to the line of best fit. Sorry, my handwriting is atrocious. Okay, find the diamond for which the model prediction is not very close to the actual price. Well, if you look, this one is a full 1,000 below the line of best fit, so I'm going to use that one, which is 1.5, 6,000. You can use a different point as long as it is pretty far away from that line of best fit. Okay, so it's not close to the line of best fit. Okay. Types of associations. Okay. We've seen 2 types of associations in this lesson so far. If we look at our diamond graph, this actually has a positive association because as the weight of the carat increases, the price in dollars also increases. So a scatter plot that can be modeled by a line of best fit with a positive slope can be shown to have a positive trend or positive association. Okay, otherwise, like this next one, negative slope would be negative association. And we kind of saw this above with the weight of a car and fuel efficiency. Now, we haven't seen an example of this one, but one that cannot be modeled by a line of best fit can be said to show no trend or no association. Okay, and no association would be one that kind of looks like this with points kind of scattered all about everywhere. Okay, we can't really tell if it's increasing or decreasing. It's just 2 variables that aren't really related to each other. Positive association is like the one we saw before, where points are kind of increasing, and then negative is where we kind of see points decreasing throughout our graph. All right, guys, go ahead and pause the video. Try 1.4, interpreting data. You're going to be choosing one of these sentences to describe the graph, and make sure you put your y and x variables where I wrote them. So x comes first, y comes next. So you're saying as x increases, what is y doing? Is it increasing, decreasing, or it's not really related? Okay, you can put a check mark at whichever one you choose, like so, and fill it in appropriately. Go ahead. Okay, for this first one, as mileage increases, so does price. So we're going to use this one and put as mileage, whoa, let's erase that. As mileage increases, price also tends to increase. My fault, that is not true. It's for these data, as mileage increases, price tends to decrease. And that's because we don't want cars that have a lot of miles on them because we are going to drive them for a lesser period of time. However, if we're on a strict budget, we may want to get a car that is higher in mileage and lower in price. If we look at our second one, this is where I'm trying to go right now. This one, as the weight of the diamond increases, the price is going to increase. Bigger the diamond, bigger the price tag. Now for this one's a little bit looser. However, if I was to draw a line of best fit, I'm going to put these together and draw a line through them. And as you can see, that line is increasing. So I'm gonna pick this first one. For these data, as high temp increases, energy consumed increases. Okay, and that's because as the higher temperatures kind of increase throughout the day or throughout the summer and spring, our energy consumed goes up because of the amount we spend on air conditioning, and we're plugging in fans and trying to cool down from the day. Okay, all right guys, you can go ahead and choose from the options on the smartboard what you guys are going to do next. Thank you for following along. I know I went really fast, but you guys got this. If you have any questions, please let me know, and we're going to have a great rest of our day.